Good day everyone, welcome to our teaching series, and today we will be discussing the first part of the topic, integration. We will be treating integration of polynomial functions. Integration is the opposite of differentiation. It is usually represented by an elongated s. Now in integration, we are basically trying to undo what we've done during differentiation. Now recall our general formula for differentiation, that is when we are differentiating a function s to the power of n, our derivatives equals to ns raised to the power of n minus 1. That is, we are removing 1 from the power and we are multiplying by the power. So in integration, what we do, we try to reverse that, and to do that we'll be adding 1 back to the power, and we'll be dividing by the power plus 1. So our general formula for integration, when you have a function s to the power of n and you're trying to integrate it, as you're trying to reverse what you've done during differentiation, it becomes s to the power of n plus 1 divided by n plus 1. So therefore the general formula for integration, when you're integrating the function s to the power of n, it is s to the power of n plus 1 divided by n plus 1. There are two types of integral. We have definite and indefinite integral, but in this class we'll be concerning ourselves with indefinite integral. We are going to be explaining this using an example. Let us check this out. Let us say we have an equation y equals to 10s cubed plus 3, and if we are to differentiate this, our dy over the s will be equals to 30s squared. Now remember, in integration we are trying to get back the original function. That's we're trying to get back y is equals to 10s cubed plus 3. Now to achieve this, the first thing we are going to do is to cross multiply. Doing so, our equation becomes dy is equals to 30s squared in bracket ds. At this point, to get y, we are going to be integrating both sides of the equation. So introducing our integral symbol, it becomes the integral of dy is equals to the integral of 30s squared ds, that is 30s squared in brackets. Now the integral of dy will be equals to y, because integral and derivative basically cancel at their opposite, so we are left with y will be equals to, now for our right hand side we have the integral of 30s squared. Similar to differentiation, when we have a constant in front of a variable, we normally don't integrate it, or in differentiation we don't differentiate it, so it becomes y is equals to 30 the integral of s squared ds. At this point we are going to be applying our general integration formula to integrate s squared. Doing so, it becomes s to the power of 2 plus 1, that's n plus 1, divided by 2 plus 1. So this will give us s to the power of 3 divided by 3. Now multiplying by 30, which is our constant, y will therefore be equals to 30s cubed divided by 3. And dividing, we have y equals to 10s cubed. Obviously, as you can see, we've only been able to get the part y is equals to 10s cubed, and we know that our original equation is y equals to 10s cubed plus 3. Now the problem with this is that there is no way to know the constant that was removed earlier. So basically in integration we just introduce a alphabet to account for that constant. So normally after integrating we add a symbol, probably most likely c or k. Doing though, adding our constant to this our final answer, it becomes y equals to 10s cubed plus k. And with our previous knowledge, the k is representing our 3, but there is no way to find that out now. But with definite integral we should be able to find 3, but we are limiting the scope of these studies to indefinite integral. We have a question that states that integrate 1 minus s divided by s cubed with respect to s. And the very first thing we are going to do is simplify our expression 1 minus s divided by s cubed by splitting the fraction. Doing so, the integral of 1 minus s divided by s cubed will be equals to the integral of 1 divided by s cubed minus s divided by s cubed. because when we split 1 minus s divided by s cube, it's equal to 1 divided by s cube minus s divided by s cube. So now we are going to be integrating it individually. So integrating it by expanding our brackets, it becomes the integral of 1 divided by s cubed ds minus the integral of 1 divided by s squared ds, because s divided by s cubed will be equals to 1 divided by s squared, which will be equals to the integral of s to the power minus 3 ds minus the integral of s to the power minus 2 ds. From indices, 1 divided by s cubed is equals to s to the power minus 3, and 1 divided by s squared is equals to s to the power minus 2. Now integrating both parts, applying the formula, it will be equals to s to the power minus 3. If we are integrating it, it becomes s to the power minus 3 plus 1 divided by minus 3 plus 1 minus integrating s to the power minus 2, it becomes s to the power minus 2 plus 1 divided by minus 2 plus 1 plus our constant of integration, which is k. Simplifying further, it will be equals to s to the power minus 2 divided by minus 2 minus s to the power minus 1 divided by minus 1 plus k. Still simplifying it further, it will be equals to minus 1 divided by 2s squared plus 1 over s plus k, because s power minus 2 is the same as 1 divided by s squared, and s power minus 1 is similar to 1 divided by s. Now rearranging, to be equals to 1 over s minus 1 divided by 2s squared plus k, and the correct option is C. Our next question states that if the y over the s is equals to s cubed minus 2s squared minus 3s plus 1, find y. Now the very first step is to write down our equation. The y over the s is equals to s cubed minus 2s squared minus 3s plus 1. Our next step is to multiply both sides by the s, and doing so, the y over the s times the s will be left by the y. It will be equals to, in bracket, s cubed minus 2s squared minus 3s plus 1 ds. The next step is to integrate both sides. So integrating both sides, it becomes the integral of the y is equals to the integral of s cubed minus 2s squared minus 3s plus 1 in bracket ds. Now integrating using our integration formula, we have y to be equals to, integrating s cubed, it becomes s to the power of 3 plus 1 divided by 3 plus 1, which is s to the power of 4 divided by 1, which is s to the power of 4 divided by 4, minus differentiating 2s squared becomes 2s to the power of 2 plus 1 divided by 2 plus 1, which is 2s cubed divided by 3, minus, when we integrate 3s, to be 3s to the power of 1 plus 1 divided by 1 plus 1, which will lead to minus 3s squared divided by 2. When we integrate 1, we get s, and we are going to be adding our constant of integration, which is c. So our final answer is y is equals to s to the power of 4 divided by 4 minus 2s cubed divided by 3 minus 3s squared divided by 2 plus s plus c. Our next question states that simplify the integral of s squared plus 3s plus 2 divided by s plus 1 ds, and we are given the option. First, we are going to simplify the numerator by factorizing. Doing so, that's factorizing s squared plus 3s plus 2. It becomes s squared plus 3s plus 2 divided by s plus 1 will be equals to s plus 2 in bracket s plus 1. That when we factorize s squared plus 3s plus 2, it's going to give us s plus 2 in bracket s plus 1 divided by s plus 1. Now, cancelling out s plus 1 from our numerator and our denominator, we will be left with s plus 2. Thus, our original equation, that's the integral of s squared plus 3s plus 2 divided by s plus 1, is equals to the integral of s plus 2 ds. Now, integrating it individually, it will be equals to s squared divided by 2 plus 2s plus c. Our next question is from 1994, and it states that integrate 2s in bracket 2s squared minus 3s plus 4 with respect to s, and we are given the option. Now the very first thing we are going to do, we will simplify the function by opening up the bracket. Doing so, the integral of 2s in bracket 2s squared minus 3s plus 4 ds will be equals to the integral of, expanding the bracket, it becomes 4s cubed minus 6s squared plus 8s, because 2s times 2s squared is 4s cubed. 2s times minus 3s will give us minus 6s squared, and 2s times 4 is 8s. Now at this point we are going to be applying our integration formula and integrating separately. Doing so, it will be equals to 4s to the power of 4 divided by 4 minus 6s to the power of 3 divided by 3 plus 8s squared divided by 2 plus c. Simplifying further, it will be equals to s to the power of 4 minus 2s cubed plus 4s squared plus c. Our final question states that a function whose derivative is 1 divided by s squared has its integral as. Basically, we are asked to find the original function that we are going to be integrating 1 divided by s squared. And from indices, 1 divided by s squared is the same as s to the power of minus 2. So therefore, the integral of 1 divided by s squared ds is equal to the integral of s to the power of minus 2 ds. Applying our integration formula, it becomes s to the power of minus 2 plus 1 divided by minus 2 plus 1 plus our constant, which is k. And simplifying further, it will be equals to s to the power of minus 1 divided by minus 1 plus k. Simplifying, it becomes minus 1 over s plus k, and the correct option is C. Here are some exercises for you to try your hands on at home. For more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can get the hard copy, or if you are interested in the soft copy, you can get it at the website at the bottom of the screen. Thank you.